Hi, good evening, good morning, good afternoon, everyone. My name is Edward Turner. I'm a student in the MSDS 530 course, and we're going to cover the survival analytics of the Titanic dataset you can find on Kaggle. And we're going to look at things from a descriptive point of view, diagnostic point of view, predictive point of view, and prescriptive. So let's begin. So, first off, let's try to establish the problem statement so that we understand where exactly and how exactly we're going to analyze this information. So, we're going to understand patterns that are associated with the survival of a passenger on the Titanic. We're going to explore multiple analytic approaches. We're going to look to predict the likelihood of this particular attribution of survival and suggest maybe course of actions based on what we've discovered and learned. And we're going to have a holdout set during our unsupervised approaches and use it for a supervised model. Again, the predictive aspect. So we're going to look at these three things and try to understand what it means to survive on the Titanic. Now, as I mentioned before, the Titanic data set is what is used. You can find it on Kaggle. You can also download it local and use it locally. The fields that we'll consider is the class of the passenger, the sex of the passenger, the age of the passenger, the fare they paid, uh, where they embarked from, whether they have any siblings or spouses on board. We're going to look at the whether they are a parent or a child of any of the passengers on board, and we'll look at the survived attribute, which is the one or zero, the yes or no. There's a decent mix of categorical and numerical variables. We're going to dive into those themselves and understand each of the components thereafter. So this is how we are going to plan our general workflow. We're going to prepare our data. We're going to impute any missing information, encode any information as well, such as the categorical information. And then we're going to explore these distributions to further understand what's the general bias of our information is going to be. Then we're going to just use logistic regression and use that as our baseline and then evaluate on what we have held out, which would be the test set. Then we'll offer some suggestions on how the planning should go thereafter for the Titanic. So this is the survival by class. So this is how we should view things, look at things when we consider the class of the passenger and how they've actually survived. And so the survival rate is pretty interesting here because the mean is just the average of that one and zero variable. And we see that if you're in the first class, you're very likely to survive. If you're in a second class, you're a little less than a coin flip, but not too bad. But if you're in the third class, your survival rate was pretty bad. Uh, it's something to keep in mind as we consider other variables. But again, this class variable is going to have a high indicator whether you survive or not. Now, this is our general distribution of our passengers. And as we can see here, the average passenger uh, age is probably closer to 25, but it's between 20 and 30. And if you actually look at the tails, you might even think maybe 15 to around 45 is a decent pool, maybe the 50th percent or 50% of the passengers uh, closely fit underneath this particular age range, but if you can tell, this is follows a skewed distribution. Seemingly, is left skewed, meaning that the average is, or the median is quote unquote, uh, on the left side of what the mean would be. So, yeah, very interesting data set overall. Now we have what's called a right skewed, where essentially the distribution of the fares are all towards really the cheaper fare prices, which generally makes sense considering that majority of the ship probably had tickets that were uh, priced so then that more people can join. So very interesting altogether. And so these are the types of questions we're going to ask ourselves to understand how or whether someone survived. We're going to look at different groups. We consider family sizes, the class as well, and consider which ones had lower survival rates. We're going to consider how age and the fare for the ticket interacts with the class and gender. And then we're going to consider the embarkation port and how that played into it. So again, we're going to look at these features and variables: class, sex, age, fare, the family count, and embarked. We're going to do some pre-processing of the missing information. So we're going to do a median impute, and then most frequent impute for categoricals, followed by a one-hot encoding. And we're going to use logistic regression as a baseline model. So this is the result of our model result after training the model on top of the pre-processed data. And we see here the accuracy on the test set was about 77.6%. And if we look here, we see that the true zeros, aka those who didn't survive, uh, make sense as it predicted fairly well who didn't survive. It did predict someone who did survive, but also had a very interesting scenario where it didn't predict properly on some subset people. So some people that were predicted that they survived didn't actually survive, and that's around 22. So 22 people of the test sample, quote unquote, should have survived by the model's estimations, but actually didn't survive based on the data. And also somewhat similarly around 22 that didn't survive that actually did. And so it gives us an understanding of some of the drawbacks, some of the limitations of this particular model uh, as a whole. Now, this is the code to reproduce. So we use sklearn, scikit-learn as the main function or main machine learning framework of choice in this particular scenario. As you see, we're using the column transformer along with a simple imputer on the variables, on the numeric variables. And then we have a categorical pipeline as well, where we impute by most frequent, and then we do one hot encoding on the sex, where they embarked from, and then the class. And the general idea, and the reason why we do this, is logistic regression. If we didn't use one hot encoding, it may infer a linear relationship between the individual categorical variables and the output, which isn't true. We may actually have a nonlinear relationship between the categorical variable individually with the output variable, the target variable, which is whether they survived or not. Now, the one assumption, of course, that the logistic regression model does have still is that there is a linear relationship between the variables in between, and that these variables are also uh, linearly independent of each other. So this is just a bias of the model itself, and the only way to evade this particular bias is to use a model that's immune to that general assumption, which would be a decision tree based model coupled with gradient boosting techniques. That would be one of the main ways to avoid this general assumption. However, it also would include additional hyperparameter tuning, which would take time. However, if we were looking to find a model that is the most optimal, then we would pursue that route. We also would probably choose different metrics of choice. We use accuracy as it's a means of interpreting the results that are generally accurate in a sense of what we're trying to capture. But ideally, we should consider uh, perhaps the F1 score or the macro F1 score, where we look at the metrics precision and recall, and we try to find a model that predicts the ones very well, along predicting the zeros very well. And that gives us a model that kind of treats the binary problem as more of a categorical problem. And that's something that would allow us to understand more in depthly the actual issues. But for this particular uh, problem, this assignment, we're going to decide using logistic regression as it's a model that we can train more quickly and we can explain more easily, given, again, the architecture of the model. So here are some ideas that we can employ when trying to improve the survival of the passengers on the Titanic. So one thing is to prioritize the evacuation for the at-risk segments. So people with large families, uh, people that were in the third class, as noted previously, the third class, or passengers who were in the third class had very low survival ratings. So it would really ensure that more people survive. We also should improve the route signage and staffing where crowding is likely, so thus preventing any blockages and optimizing the amount of people that would survive. And we also look towards resource allocation and looking at lifeboat capacity limits and seeing if there's a way to increase those so that way more people can own a lifeboat, thus, again, optimizing for the amount of people that has actually survived the Titanic. So these are the steps to solve the problem. As I mentioned before, we would look towards uh, F1 as a whole, but we still want to look at recall because we do want to capture more people that would be in the positive class because we did miss those. And we want to make sure that we are predicting like if someone would survive and be able to find those people. So we would want to still prioritize recall in that particular scenario on the positive class. Still, ideally, we should have the F1 score be used as a means of optimizing for predicting like if someone doesn't necessarily make it, because the con of using recall is you could predict everyone is going to survive, which means recall would be really high, but then precision will be low. So still, we would want to prioritize the macro F1, but if there's a way to look at the problem and one if we just want to focus on the survival, then that would be looking at the recall in the positive class. Uh, we would also continue iterating different alternatives. As I mentioned, tree-based models would enable us to have more non-linear relationships between the features in themselves and those their said combinations on the uh, survival variable. And I mentioned gradient boosting. Gradient boosting is a subclass ensembles. So we could look at also random forests. We can look at extra trees as well as different ensemble methods for classification. And these are the type of techniques that we could look to utilize in the scikit learn approach. If we wanted to do overkill and employ a deep learning approach, we can most certainly do that. And we can look at ways of embedding the different classes. We can look towards different ways of looking at the age as well, and perhaps doing bucketing and then employing those as embeddings and saying that there's a different embedding for each bucket and employ different activation functions. So we can get more complicated. But I think for the use case of solving this problem without having to go overkill is to just simply employ uh, ensembles on top of gradient boosting trees, random forests, and extra trees classifiers on that information. And there's different gradient boosting trees. You have what's provided through scikit-learn, you have XGBoost, you have light gradient boosting, you have cat boost. There's a lot of options that you could use to solve this problem. Now, there are risks involved, as of course, there are risks with everything. So you're going to have historical biases. You're going to have, again, missingness and measurement error. So how we handle missing information is going to impact the model performance. One way we could mitigate that is by assuming that the missing value will be imputed by a category called missing, and we would have a categorical one, or we'll use one encoding on that category variable just to denote that it's missing. So therefore, the model would be able to infer that in the case of missing information, consider other variables potentially in its estimation. So that's one way of performing that particular approach. But again, we may have issues for that. And then we're going to have, of course, this combination of model simplicity and predictive power trade-offs. Logistic regression is a simpler model, but may not be as powerful in a predictive standpoint. But a model, say, like XGBoost classifier, may be extremely powerful, but when it comes to really explaining the underneath aspect, it may be complicated to do so. So, again, these are some considerations for these approaches. Now, in general, as we stated before, the class is strongly associated with survival. We saw that. But the gender as well, the sex as well, is also associated strongly with survival. And you saw more women, more females being individuals that survived more so than the males. And so we have that as a measure to understand who's most likely to survive. We also have FAIR, so which is a wealth proxy that's tied to high survival probability. And we also have family structure influences that would influence again the mobility axis. So um, women and children are prioritized from a family unit perspective over the male, the husband. So we have that consideration as well. These are the references I use against the Kaggle Titanic data set. You also have a couple different sources that I use for clustering, finding different groups in the information data, also ways to group to optimize objective functions. So these are all additional references that I've read and considered throughout my analysis. All right. You have time for Q&A. Thank you.